Okay, so grade 10s, we're on lesson 8 right now. So we're talking about, there's a special notation that we use for when something is a function. So on that page that I made you in the template notes, it starts off with a little bit of review. All right, this is just connecting. Struggle. There we go. So a function is where each x value, or our domain, has exactly one output, or range, or y value. We use the vertical line test to identify if something is a function or if it's only a relation. I just want to draw an example because I think this is something good for us to review, but this is just purely review. So a function could be something if it starts here, goes like this. That would be a function. I can draw a straight line all throughout this graph, and I'm never going to hit that line multiple times. I'm only going to hit it once. Lovely. So this one would be a function. If it's a function, it's also a relation. Because remember, a function is like a subcategory. Versus a relation, it won't pass that vertical line test. So a relation could be very similar, but maybe I have a point here and then a point here, and my graph would continue. So you could have it like broken up like that, or this could be a connected line. Regardless, when I draw a vertical line, I hit 2 points. So it's not a function, but it's still a relation. That should just be review. Charlotte? No, because you're not graphing something that's not a relation. Good question. It's like a relation is just whenever you're comparing two things. So for you to be able to graph it, you're comparing like an x and y right away. So I've made up this table below. I want you guys all to take a second and look at it and see if you can spot the difference between my left column and my right column. Don't think too hard on this.
Yeah, there's like a apostrophe, a letter with an apostrophe.
Do you know what an apostrophe is?
Not an apostrophe bracket.
Good. The first one, this is a Y, and then it became an F and an X. The second one, this was a Y, and then it became an F and an X. Third one, it was a C, and then it became CP. Notice there was a P variable on the inside. Last one, this was a V with a T. Now it says V of T. Function notation, that's all they're doing, is changing Y equals to be this different setup. All the points of this is like when you're using function notation that's called, is it tells us, oh, look, it's a function. It doesn't, like, I think your workbook really overcomplicates this. So if you turn the page, instead of writing Y equals, all you do is you're going to write F bracket X. That is the only difference. This seems really complicated because for the last, I don't know, 4 or 5 years, you've always written Y equals, and now we're going to write F bracket X equals. It's the same thing, has the same meaning. It just identifies, it's like, hey, I'm telling you, this is a function, versus before, you don't know if it's a function or a relation. Good question. Why do you do this? Right now, it's going to seem like we're doing this for no apparent reason. This becomes a lot more helpful when you get into higher mathematics. So we're like laying groundwork right now. You can ask questions differently, and it actually presents the questions a lot more clearly once you get used to it, especially if you take calculus in grade 12. I'll go through it, but yeah, yeah.
So how come like function right here on like the C and V?
I'll go through it. I'll go through it. Okay, so this next little bit is kind of explaining it a little bit more. So we read this, or we would say it's function with input of x, or we would say f of x. So that's what's written here in my little clip art thing. So when it's written like that, we say f of x. Really, really important. It's not multiplication. I know there is a letter next to brackets, but it's not multiplication. Don't think it is. What it means, so the letter in brackets is just the variable you're using in the question. F, we use F most often because it's saying function in like the most generic sense, just like we often use Y because it's kind of just in general. Like Camden was just saying in the one, it said V for value, so they used a V instead of function because it's like slightly more specific. That's it. So if I had an equation that was like B is equal to 2A minus 3, in function notation, we would then say B of A, because A is that variable on the inside. So whatever variable you're using, that becomes what's in brackets initially. Generally speaking, we use F of X when it's like in general terms. Sometimes we'll use G, or sometimes we'll use H as well. Why they chose those letters, I don't really know. Alphabetical is my guess. So you could write an equation that's y equals 2x minus 3. In function notation, that might be like f of x equals 2x minus 3. Or it could be g of x is equal to 2x minus 3. Or h of x is equal to 2x minus 3. All of those mean the exact same thing. Instead of writing y, we just change the initial part. And we'll go through some examples to kind of explain why. But that's it. All you're doing is changing your y to this different way. I like your workbook from this point on, so we're going to turn to page 466 at this point.
What if it's like y for p?
So then it's going to be, yeah, then you'd use p in your brackets. Whatever the variable is, that's what goes in brackets. Andy. Equals like this, like that. So then you would first make it like add 3 to both sides. So it was a y equals x plus 3. And then you would do f of x is equal to x plus 3. I'm not going to give you ones like that because that's coming into a little bit more of actually our like following unit that builds on this stuff. That will come into play, but just not right now. Okay, so I just felt like your first page in your workbook, so page 465, made this much more difficult than it is. And it really isn't. We're just replacing y with f of x. So I do like their examples, so that's what we're going to go through. So there's a lot of different ways to ask these questions. So a lot of this is terminology, and a lot of it just seems scarier than it is. And so I really want to like downplay it with you guys right now. So consider the function f of x is equal to x squared plus 5. So that's our first equation we're going to be looking at. The second equation is g of x is equal to 4 minus x. So previous to this, we might have just seen this as like y1 is equal to x squared plus 5. And then it might have been like y2 is equal to 4 minus x. Right? It's just like, here's two equations. We're going to answer some questions based on these equations, is what it's telling us. So the first one says, evaluate f of 3. So there's a 3 in brackets, so we're going to replace all x's with the 3. So instead of writing x, because x is what was there before, I'm going to sub in a 3. So my initial equation in the f of x is x squared plus 5. So now I'm going to change it to be 3 squared plus 5. 3 squared is 9. 9 plus 5 is 14. For your guys' sake, like when you're writing this out, you could go straight from here to here and only write those 2 lines. I'm just trying to show you a little bit more. What this means is my x value is 3, my y value is 14. Seems more difficult, but that's all it's getting at. All you did was plugged in 3 and you solved for y. Second example is g of 1. So now it's saying, let's use that second equation. So now I'm going to use this one. So I'm going to use the 4 minus x. So now it's going to become 4 minus 1. I'm just going to replace the 1 and the x. 4 minus 1 is 3. So you're done at that point, but I just want to like remind you what that's saying is in this scenario, x is equal to 1, so y is equal to 3. If I wrote that as like a graphing ordered pair, that would be 1 and 3. So there's like a lot of different meanings behind all of these things. End of the day, we just plugged in an x value and solved for our y value. So C says f at -2. So looking at our first equation, we're plugging in -2. So notice I put it in brackets because it's being squared and I want that negative included. So -2 times -2 gives us 4. So our final answer there is 9. All we're doing is replacing our variable with whatever is in brackets. G at -2, so I would use 4 minus -2. You don't have to write brackets, but sometimes it's helpful to write those brackets. So I get 6. 4 plus 2 is 6. E is where it gets to be a little bit more difficult. We're looking at both equations now. So my first equation is f at 0. So I'm going to have 0 squared plus 5 minus our second equation, which is 4 minus 0. So I'm trying to color code this for you guys. 0 squared plus 5 just is 5. 4 minus 0 is 4. 5 minus 4 gives us a final answer of 1. And that's like as difficult as these can get, combining two equations into one. So in this one, you would just write equals 1 like that. This is like laying the groundwork for it. So when you do calculus, eventually you're going to draw like 2 lines on a graph. So one line would be like the f equation, the second line would be your g equation, and then you like turn them and you calculate the area between the two, and this is getting at where that's coming into play. So right now, like, this has no context and no real application, but it really does once you get to calculus. So it's kind of difficult right now, but you're capable of learning this right now versus you need to learn a lot more to get to calculus, so that's why they put it here. Okay, looking at this next one, consider the function defined by this, where x is an element of the reals. Again, fancy way of saying, look, we're going to look at this equation, f of x is equal to 5x cubed minus 2x. Here's an equation. We're going to look at different ways they can present basically the same question, just with different wording. So f at -3, again, just plugging in -3 instead of x. So this is going to be then 5 times -3 cubed minus 2 times -3. You have your calculator with you, you can go through this whole thing, but this would then be like 5 times -27 minus -6, which gives us -123. Oh. Yeah, -123. Plus 6? Oh, no. 35. Which then gives us -129. Same question written slightly differently. The value of f when x equals -2. Same way of just saying f of 2, but written slightly different. So then I have 5 times 2 to the power 3 minus 2 times 2. which is 5 times 8 minus 4. 40 minus 4 gives us 36. So basically, they have given you 3 different ways here to ask the exact same question. This last one is probably the least common you're going to come across. It's something that like is a thing that's not used very often. You'll probably only see it in grade 10. Sorry, Camden.
So how does like the XPR change?
It doesn't. It's just, it doesn't at all. It's just like saying you could have any value for X. In all of these though, that's always the case. They're just saying sometimes they might say it explicitly and sometimes they won't. Good question. So for C, the image of 7 under F. Very, like a not very common way to ask that, but again, same thing, F of 7 is equal to what? So we're going to sub in 7. So when I do this one, I'm just going to go straight to our final answer. Just different ways of asking the same question. You have to be aware of all the different ways. So E gives you this hint at the beginning, an expression for F of A. So whenever it says an expression, you're not solving. You're just going to get something with variables still in it. So now instead of writing X's, I'm going to write A's. So we're just like swapping them out. So this is then going to become 5A cubed minus 2A. Done. An expression for F of 2X. So again, we're just subbing it in. You always have to simplify it though if you can. Go ahead, Andy. You can. So like I could have rewritten it like this. So this one's going to become 5 times 2x cubed minus 2 times 2x. So if you can simplify it, you should. So 2x cubed is going to become 8x cubed. 2 times 2 gives us 4x, and now I can multiply my coefficients here to get 40x cubed minus 4x. So if you can simplify, you should. So in this unit, we're going to pull in our first unit from the year, multiplying polynomials. So looking at this next example, we have this equation. Notice they said P of X this time, just to switch it up. Means the same thing. Determine a simplified expression when it's X minus 3. So instead of writing X, I write X minus 3. And then we have a lot more cleaning up to do here. So this one's going to start out 4 times X minus 3 squared minus 6 times X minus 3 plus 1. Go back to the beginning of the year. X minus 3 squared, we have to do FOIL here. So I'm going to expand it out first just because visually that's super helpful. Do you have to? No. The second portion, I'm going to multiply in my 6. So that's going to become minus 6x plus 18 plus 1. So this chunk became that. So now I can do FOIL. So first, outer, inner, last. Minus 6x, 18 plus 1, I'm going to combine to give me 19. So a lot in this one question. I'm going to clean up my factoring portion of this, so my yellow portion. Let's clean that up a little bit more. Again, I'm showing lots of steps here. By all means, you can show less if you're able to. If you're not able to, that's just fine. So this is then going to become x squared minus 6x plus 9 minus 6x plus 19. Now I can multiply in that 4. which gives me 4x squared minus 24x plus 36 minus 6x plus 19. Our final step here is just combining all those like terms. So I have 4x squares, but then I have minus 24 minus 6, so that gives me minus 30 x's in total and 55 ones. Questions like this is a really good like level 5-6 question. 2 units together in one. Okay, consider the function f of x equals 10x minus 3. So determine the value of x if f of x is equal to 47. So this is slightly tweaked than all the ones previous. Now it's saying, what is x if y is equal to 47? So we're going to substitute in 47 into the f of x spot. So I'm going to get 47 is equal to 10x minus 3. How do I isolate and solve for that x? That's my first step. Good. So then 50 is equal to 10x. To get rid of that 10, I divide both sides by 10. So for B, solve the equation. So again, it's like my y value is negative 23. What is our x value? So I'm going to do negative 23 equals 10x minus 3. And then the exact same process. Add 3 to both sides. Be careful. Negative 23 plus 3, I'm going more positive. So I get negative 20 equals 10x. Divide by 10. So negative 2 equals x. How is that? Somewhat okay? Okay, turn the page over. Evaluate f of 4. What do I do here? Good, right on. So then this one's going to become 4 squared minus 5. So 16 minus 5 is 11. Versus B, solve the equation of f of x equals 4. So notice that ever slight difference here. F of 4 was in brackets. Now it's equal to 4. So what that means is my final answer is 4. What is x? So then I'm going to write 4 equals x squared minus 5. Add 5 to both sides. So the 9 is equal to x squared. How do I figure out what just x is? Good. What is the square root of 9? But it's also what else? Good. Positive and negative 3. I wrote that funny. It's really important that you're recognizing that it's positive and negative 3, because what that means, if you were to graph this, you would have a coordinate at 3 and 4, but you also would have a coordinate at negative 3 and 4. So there's actually 2 different points there. So it's really important that you're recognizing that. I get that it's something super easy to forget, because 1, your calculator doesn't remind you, and 2, it's something that we don't always expect you to say. Question C, they've added this piece of information where t has to be greater than 0. So they've slightly changed it here. So now it says f of t is 75. So now they're saying 75 is going to be equal to x squared minus 5. So I add 5 to both sides. X squared is equal to 80. Square root that. And I'm going to get like 8.9. But because they said it has to be greater than 0, it's only positive 8.9. So earlier, Camden pointed out, he's like, what does it matter if that x being an element of the reals or not? In this scenario, they've limited us to only care about positive x's. So in this one, it would only be that 8.9 and 75. Only the positive option of it.
Why do we do that?
Because they told us t has to be greater than 0. So I can't have a negative. Andy. Because when you take the square root of a number, it's always the positive and negative, right? Because -3 times -3 gives us positive 9, just like positive 3 and positive 3 does. So that's going back to like principles of square roots. Right? Like if when you first learn what a square root is, we know 3 times 3 gives us 9, right? But so does -3 times -3. So when I take the square root of 9, there's 2 ways I can multiply the same number to get there. So that's why we say it's positive and -3. Yeah. It's important. Questions like that, I will usually like lead you slightly to like get that there's 2 coordinates, because I get that we don't emphasize it a lot. But yes, you would be wrong if you only wrote down 1. Okay, we're going to go on to lesson 9. These are the practice questions for lesson 8. Lesson 9 and lesson 8 are like the same lesson. Why they split into 2, I really don't know. So those are the questions I want you to do in lesson 8. So if you want to take a second and circle them right now, then we're going to turn to page 471. You're going to have time tomorrow to work on them too. No, but partially. They should be the same lesson. Yeah. I don't know why your workbook splits them into 2. It's like the same stuff.
They're not the same lesson, but they should be.
They should be. Okay, write down these questions. Yes. Yes. Okay. Turn to lesson 9, grade 10. Okay, so I'm going to go right down to class example 2. We are not doing, we're going to do 2 examples here, grade 10s. That's it. Gentlemen, class example 2. So in each case, express the function notation as an equation in 2 variables. So now it's like go backwards. Write it as you're comfortable seeing it. All we're going to do is change it to be y equals 7x minus 23. Brady, write this down. In the second one, it says g of t is equal to all of that. Now we can just write, if you wanted to, you could write it as g. Generally speaking, we use y, so I'm going to keep it as a y. If you wanted to change the t's to x's, go right ahead. Doesn't matter. So now we're just going backwards the way we normally see it. That's it. They would say that, though, as an equation in 2 variables. Gentlemen. So write this down. Why exactly? Express. Okay, express the relation y equals 11x minus 15 in function notation. Just change the y to f of x. Another way you might see this being asked, the graph of a function is defined as y equals f of x. It has the equation y equals 4 minus 3x. Express this in function notation. This whole chunk we don't even care about. Express that in function notation. So again, we just are going to change it to be f of x is 4 minus 3x. Not very difficult, but they can present this to be worded very difficult. And it's annoying Okay, last example. Last example is actually relating this to a graph, and then that's it. This is an area where I find we struggle a lot. So let's really listen and look at the board and make sure we write this down. So the graph of a function is shown. So this graph would be like from data. It's not able to be represented by an equation, but it still can be a function. It has clear start points, end points, etc. So question 1 says f of 5 is equal to what? So what that means is my x value is equal to 5. We're going to look on our graph and see what our y value is when x equals 5. So if I go over to 5 and I go down, I get this point right here at -2. So you have to utilize your graph. So you're just looking at the coordinates, and there is a point at 5 and -2. Part 2, below in B is where you write the coordinates. I just wrote it above. They gave you space. F at -2. So I'm going to go horizontally -2, and I'm going to find that point there. So that's at +3. So the coordinates would be at -2 and 3. It's the same thing, just a different way of asking. F of 4, so go horizontally 4. Find your y value, and that's going to be at -1. So I would have coordinates at 4 and -1. So it's reading your graph and being able to interpret these questions and knowing what they're getting at. C, state the values of x. Notice they said value with s in brackets. There might be some cases where there's 2. So when y is equal to -1, so let's find y is equal to -1, and that's right there. That's where it hits. So x is equal to 4 there. When y is equal to 3, so I'm going to go up to 3. I find it helpful to draw a horizontal line to like visualize it a little bit more, because that's all the points where y is equal to 3. There's 2 spots where y is equal to 3. So our answer here is when x is equal to positive and -2, is that? Oh, I drew my line wrong, that's why. Up here, there we go. So positive and -2. There are coordinates for x at positive and -2. Y is 3 on both of those. So the last one, when y is equal to 4, it also crosses twice at positive and -1. Andy? Like this f way up here? Yeah, that just means like the x value is equal to 5. Okay, so D, use the notation to make a statement about points A and B on the graph. So using function notation. So point B, or let's do point A first. So point A is over here. The coordinates of point A would be at -5 and +1, correct? So using function notation for A, we put our x value in our bracket. So it's going to be f at -5 equaling our y value, which is 1. Our coordinates for B are at 6 and -3. So then we would say f at the x value of 6 equals our y value of -3. So it's just a different way that you can write your ordered pairs, so you can write out your coordinates. Write x and y intercepts of our graph using function notation. So let's do our y-intercept first. Our y-intercept is where our graph crosses our y-axis. It's always where x is equal to 0. So we know right away it's going to be f at 0 equaling something. Look on your graph, crosses our y-axis at 5. Your x-intercept is where it crosses your x-axis, and it's where y is equal to 0. Oops. So if I look at my graph, it crosses my x-axis here and here. So I have f at -6 equals 0, as well as f at 3 equals 0. So on this question, I've shown a little bit extra, like your answer would just be the highlighted version. I think it's a really good habit to always write down x and y equaling 0 because it's just that reminder, but you don't actually have to write it out. Okay, the last ones, coming back to like circle around to where we started in this unit. The domain for f, so all of our f values, all of our x values, horizontally, they go as the lowest at -5, all the way to a maximum of 6. Our y values go from a low point at -4 to a maximum of 5. So we have, it's a little bit less today because today's Tuesday. So we have 20 minutes in today's class to work on some practice questions. Tomorrow I have a fun murder mystery activity for us to do. It won't take the whole class, and you'll also get some work time on these. Okay, so these won't be due for tomorrow. Yep. Because my x value goes, so there's not an arrow on the graph. So your x value goes all the way to -6. It goes past -5 though. It goes past point A, doesn't it? Yeah, so it goes all the way to the point where it touches our x-axis at -6. I shouldn't have, because I suck. -6. And then it actually goes, then you're right, further, doesn't it? It goes all the way to 7. 5, 6, 7. I struggle to read when it's on my screen. Yeah. Yeah. So grade 10s, you are starting with lesson 8's practice questions. These are the ones for lesson 9. Here, I'll post them both here. So you have 20 minutes right now to work on practice questions. I'm going to just post them all on my page so you can see it a little bit better. Gentlemen, you're bothering me. You're very distracted. So these are the practice questions you were working on. No, you were not going to the hallway today. Because you talked through half of my lesson right now. Why would I reward you?